Welcome back to physics online class. I am Parth Davda and this video is for class 9. Today we are going to learn about equations of motions by graphical method. So basically we will be deriving the equations of motions, and previously we have finished basic concepts, displacement and its numericals, and acceleration and its numericals. All those videos you can have a look at the description below. So let's begin with the definition first. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion, and the distance covered by us by certain time. So here, as you can see, there are four quantities that we will be able to define in the equations, and this set of equations are known as equations of motion. That means that this four will be related to each other in the motion equations. The very first equation of motion is v equals to u plus at. The second equation is s ut plus half at square. Third equation is 2as equals to v square minus u square. Now few of the symbols you are already aware of, the others you might not be knowing. So let's understand them first. U stands for initial velocity, A stands for acceleration, T stands for time, V will be the final velocity, and S is representing distance. Remember, S is not speed, it is distance or displacement. So now these are the three set of equations which we are supposed to derive by the graphical method. So let's get going. The very first thing is velocity versus time graph. And here u is not equals to 0. That means the initial velocity at this particular place, we are beginning with something which is not 0. As you are already having velocity on this axis, time on x-axis, so this is how we will be able to get the whole graph. Now various sections are divided over here. So these sections we shall be naming it. So remember that these all the sections, all the things are basically on velocity and time. So beginning with the derivations, as you can see the same graph, we have now named it. OC is representing time, OE is representing velocity, OA over here the initial velocity will be u, time is represented by t. Okay, now this BC will be considered the value as final velocity v. So I hope these things are clear as of now. The velocity is changing from point A to point B, and hence that is the acceleration that we are getting during this particular region. Now if OC is represented as t, then as you can see AD will also represented by t. Okay, consider the velocity time graph of an object that moves under the uniform acceleration as shown over here. Here u equals to 0. From the graph you can say OC equals to t equals to AD, means AD and OC are equal since it is forming a rectangle. OA and CD will be equals to u. So this u over here will also be having the same value between CD. OE, this one, OE is this path, and BC this path. Again, they both will be equal, and the value of both we will be considering as v. So BD, that means this particular portion from B to D. Now consider this whole BC is V, this much portion CD is U. So if I want to find it from B to D, then that will be referred as V minus U. The whole total is V minus this much portion of CD will be U. So I hope everything is clear till here. Let's get going. First equation of motion, which is V equals to U plus AT. We will be beginning the whole equation derivation with the common acceleration formula, which is change in velocity upon time. Here, where is the change taking place? As you can see, this AB, slope AB is the place where the change is taking place. So A equals to change, that is in the which section? BD section, this section, and upon time, that is AD over here. Now BD will be how much? V minus U, as we have discussed, and the value of AD means this one will be T. So we will be substituting into the equation, and we shall get this V minus U upon this T. I hope this is clear over here, and then T at this place. Now changing the whole thing, taking the T on the other side, we'll be able to get AT, T gets multiplied, equals to V minus U as it is. So finally, if I am taking this minus U on the other side of the equation, that will be giving me something like this: V equals to U plus AT. So this is the required equation as we have mentioned beginning. So this is the first equation of motion. Let's move forward. So the second equation of motion is S equals to ut plus half at square. So let's begin. Now how will we find the distance among the velocity versus time? Well, that will be the area which is present in the shaded portion as whole. So this is the whole shaded portion, as you can see. The whole shaded portion can be divided into two figures. The very first figure is OADC. OADC, a rectangle. I hope you are able to see. This is the rectangle that we are having. The another figure which we are having is area of ABD, triangle ABD, A, B and D. So this triangle. Now, how will we find the area of OADC? That is pretty simple. Area of OADC is a rectangle. That means it will be OA, the breadth multiplied by the length OC, and area of triangle ABD means this portion. How will we find? Half into BD into AD. So we'll put it into the equation. S equals to U into T. Why? Because OA is U, here the value, OC is T, the time that we have taken, plus half into BD. Now this BD section, as we have done in the previous equation, will be V minus U, and AD. So this AD over here will be T. So our equation whole gets turned into S equals to UT plus half V minus U into T. So now V minus U can be referred as directly at. How? From the equation of acceleration. And that's how we will be getting this t, and this t will get multiplied, and we will be able to get s equals to ut plus half at square. So hence derived. Now coming on to the third equation of motion. Third equation of motion is 2as equals to v square minus u square. So distance present in the whole of this shaded portion, which we had divided into one triangle and one rectangle into the previous equation. But this time we shall consider the whole thing as a trapezium. And what will be the name of the trapezium? O over here, A, B, C. So how will we find the area of trapezium? Well, this is basic. 1 by 2 OA plus BC. That means this is OA, this is whole BC, means the opposite sides of a trapezium, the parallel sides of trapezium will be added, and it will be multiplied with AD. That means that is the height. This is the AD, height of trapezium. So let us put the values of it. What will be the value of OA? OA value will be U. BC value will be V. This one. And this AD will be having the value T. So our whole equation turns into half into V plus U into T. But T equals to V minus U upon A. Remember, we have written the equation with respect to acceleration as A equals to V minus U upon T. So if I just exchange the places, then I'll be getting everything with respect to T. So this value of T I'll be putting into the place of this. So have a look at it. The T is now replaced with this part V minus U upon A, which we got from here. The rest of the things stays as it is. Now 2 into A will be sent on the other side, transposition, and hence we will be getting 2as, and we will be left with V plus U and V minus U. Now as you are already aware about some identities such as A plus B multiplied by A minus B, that becomes A square minus B square. Similar thing will be taking place over here. 2as equals to V square minus U square. So that's what the required equation of motion was. Now talking about the uniform circular motion. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. The speed v is given by 2 pi r upon t. Now as you can see, greater the radius, greater will be the distance, and that's how the whole thing will be in uniform circular motion. The red ball will be traveling lesser compared to the cream, and green ball will be moving the farthest in terms of distance, as its radius is bigger. Another example of uniform circular motion we can have in such a manner. Here one unicycle is moving in the same place around a circle. Displacement will be 0, but distance will be some non-zero number. So if you want to find the velocity, our formula is v equals to 2 pi r upon t. Why 2 pi r? Because that is what the circumference of a circle is, and circumference of the circle will be the distance travelled in both of these cases. Let us have a look at two more examples of uniform circular motion. Now the distance traveled at different times you are able to see, and that's how we are able to get the circumference as 2 pi multiplied by radius r, and we are able to get the circumference as 2 pi r. Here it is. We'll have a look at one more example after this. Have a look at this car. The car is moving in a circular fashion, and hence its displacement will be completely zero. But the distance traveled by this car will be the circumference of this whole circle. So that's how we'll be able to get 2 pi r as the total distance traveled in this case. I hope this thing is quite clear. So students, this is the end of 3 equations of motion and uniform circular motion. We have finished the derivations of all the 3 equations, and these 3 equations will be used in the numericals which we will be performing next. Numericals based on equation of motion. Previously we have finished the derivation of all the equations of motion. So let's begin. A bus accelerates uniformly from 54 km per hour to 72 km per hour in 10 seconds. Calculate acceleration in meter per second square and distance covered by the bus in meters during this interval. So students, here we are supposed to find 2 things. So we will be beginning from the acceleration, as you have already learnt about it. So I hope that you can remember and recall the formula to find acceleration. So let's absorb the data. Let's find what all things are given. U is 54 km per hour, V is 72 km per hour, and time t is 10 seconds. So when we convert it into the standard units, we will be able to get 15 meter per second, and V equals to 20 meter per second. So I hope these absorption of the data, collecting of the data is clear. So let's move ahead. The formula of acceleration is V minus u upon t. Substituting all of them, 20 minus 15 upon 10, which will give us 5 upon 10, which is nothing but 1 by 2, and in decimal digits we will be expressing as 0.5 meter per second square. This becomes our first part of the numerical, that is acceleration. Now we shall be going ahead with the second part, that is finding distance. Distance covered by the bus in meters during this interval. First of all, we will be jotting down all the data that we are having. U, T and A, acceleration. The data is in front of you over here on the right side. Now the second equation of motion. So let's begin with the substituting of the values. So U is 15, T is 10, half, A is 0.5, and remember, always remember to keep this as T square, and hence implement the same thing over here, T into T, that means 10 into 10 in this particular case. And now simple math, this becomes 150, 0.5 times 10 becomes only 5, and this becomes as it is, carry forward 10. So we just have to multiply 5 into 10 will be 50, and at last we will be getting 150 plus half of 50 over here will be 25. So 150 plus 25 will give us 175 meters. So this is the distance traveled by the object during the interval that was suggested. So I hope this kind of numericals are pretty easy and clear. You can use any equation, second or third equation, for finding S depending on the availability of the data. So let's begin with the second numerical. A bus starts from rest and acquires a velocity of 72 km per hour in 2 seconds. You have to find acceleration and the distance covered by the bus during this interval. Now since it is beginning from rest, so our u will be 0 km per hour or meter per second. Our v will be 72 km per hour and time which is given as 2 seconds, so we have taken 2 seconds of time. We need to convert it into the standard units as we were doing it in all the numericals. So let's convert it. U will be remaining as 0, V will be 20 meter per second and time is already 2 seconds. So finding acceleration again, V minus U upon T. 20 minus 0 upon 2, that will be 10. So acceleration is 10 meter per second square. Let's move with the flow and go on to the second part of our numerical. The second part is asking us distance covered by the bus during this particular interval. So as we had done it in the previous numerical, the same procedure we shall be doing. First of all, the data is on your right hand side so that you can see it all the time. So now using again the second equation of u is 0, t is 2 seconds and a is 10 meter per second square. Substituting the values, we will be able to get 0 into 2 plus half into 10 into 2 into 2 because it is t square. Remember this t square. Now simple math again. So this will become 40, multiplication of 10 into 2 into 2 and the other part will remain as 0. So half of 40 will be giving us 20. So hence we will be getting the answer as the distance traveled in this particular case will be 20 meters. I hope it's clear till here. So we proceed further. Numerical number 3. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. So here the things have changed a bit. The bus is starting from rest. That means your initial velocity will be 0. Moves with a uniform acceleration 0.1 meter per second square. That means 0.1 meter per second square acceleration is also given. For 2 minutes time is also given. So let's see what we are supposed to find. We have to find the speed acquired. That means the final velocity. And the next thing is the distance traveled. Here the things have changed. First of all, we shall be absorbing our data. U will be remaining 0 since the object is beginning from rest. Then your acceleration is 0.1 meter per second square, which is given again. And your time is 2 minutes, which is nothing but 120 seconds. So we shall now be converting all the things into its standard form. So u will remain as 0 meter per second. Time will be 120 seconds since 1 minute is equals to 60 seconds. Let's begin with the first part of the equation, which is asking us the speed acquired, that means the final velocity. So the first part is about finding the final velocity, that is the speed acquired. We have u, initial velocity equals to 0 meter per second, time t equals to 120 seconds, and acceleration, which is 0.1 meter per second square. Now we will be substituting all these numbers in the equation. At this place we will be using the equation v equals to u plus at, which was our first equation of motion. So let us substitute the values. V equals to 0, which was u, a, that was 0.1, and t, which is 120 seconds as shown earlier. Simple math, and then we shall be getting v equals to 12 meter per second. This becomes our final velocity for the numerical. So we have got the speed acquired as 12 meter per second. Now we will be going for the second part of the numerical, which is about finding distance traveled. So just for your reference, I am putting all the values on the right hand side. Here, as we have discussed earlier, as we have solved it earlier, we'll be putting the second equation of motion, which is s equals to ut plus half at square. Substituting the values, u is 0 into 120 plus half into 0.1 into again t square, that means 120 into 120. When we solve it, we will be getting 0 plus half into 1440, that is 1440. So half time 1440 will be 720 meters. So the object has traveled 720 meters in this particular time duration. I hope the concept is clear. I hope this video was some help to you. Thanks for joining. Stay tuned for more of such videos. Goodbye till then.